In this lecture, we will discuss about SR NAND gated latch. That also positive level with a positive level. Okay. So this is the symbol. So it contains three inputs, two are data inputs SR. One is control input. We can call it as enable or clock. It will work with the clock levels. Okay. So here we take in positive level means its value will be 1. Clock or enable value will be 1. It means it is working with positive level trigger. Okay. Their outputs are 2, Q and Q bar. Okay. So we have to write straight to S Q. In the diagram also straight to S Q. So why it is called gated latch, we'll see. Okay. So whatever the input side, two NAND gates are there, these are called gated part or driving part. And these last output side, two NAND gates are called latch part. This two NAND gates nothing but non-gated latch part. Okay. Suppose if you take a bus, driver will be at the starting. So that's why this is called driving part or gated part. Okay. This is the latch part. So latch part at output side, driving or gated part at input side. So in the non-gated latches, these gates are not there. That's why that is called non-gated latch. Okay. Right. See the construction here. Yes, we connected to this, or we connected to this gate, and the clock is common to both gates. Okay, this is the construction. Now we'll see the working. So before going to further process, we should have this latch truth table. This latch is a non-gated SR latch. So that truth table we should have. So I taken the truth table in a simplified way. So we know from the non-gated SR NAND latch, when inputs are 0, 0, we get invalid. When inputs are 0, 1, it means S0 or 1, we get set 1. And when S1 or 0, we get reset 0. And when both inputs are 1, 1, it will be hold. Okay. So in any gated latch or flip-flop also, the design process is after drawing this symbol and logic diagram and this latch truth table, non-gated latch truth table, then we have to do characteristic table. Then we have to do excitation table. Then we have to do characteristic equation. These are the steps. Okay. So this is step 1. This is step 1. This is for step 2, not step 2. This is for step 2. Then this is step 2. Then step 3. Step 4. So these all 4 steps are common to gated latches and flip-flops also, for both any gated latch and any flip-flop. Okay. Now we'll see how to do characteristic table. So in the characteristic table, generally we take the inputs and present state and then we predict next state. Okay. So here the format is we take enable or clock. So I mentioned this is positive level. So positive level means it will work whenever we apply 1. Okay. And we will see what happens when we apply 0 also. For positive level, if we apply 0, what will happen? 0 means negative level. For positive level circuit, if we apply negative level, what will happen? And for positive level circuit, if we apply positive level only, then what will happen? Both will see. Okay, right. Suppose when I apply 0, it means for a positive level circuit, if I apply negative level, whatever the data inputs, SR can be any value. It can be 0, 0, 0, 1, 1, 0, 1, 1, and QN value also can be any one. Whatever it may be, it will become hold. Okay, Qn n plus 1 become Qn only. Okay, so here in this condition, circuit is not triggering because not triggering means positive level circuit will respond to only positive level, not to negative level. It is not responding or not recurring. However, it is in previous, it will be like that only. There is no change in the circuit. That's the meaning. Okay. Now we'll see what will happen if we apply positive level. Okay. So how to write this S value, R value, Qn value, we'll see. Suppose there are two inputs, means four combinations, 0, 0, 0, 1, 1, 0, 1, 1 will come. So this Qn can be 0 when inputs are 0, 0. Or it can be 1 also when inputs 0, 0. And Qn can be 0 when inputs are 0, 1. Or it can be 1 also when inputs are 0, 1. Like that, Qn can be 0 when inputs are 1, 0. Or it can be 1 also for 1, 0. And finally, Qn can be 0 for inputs 1, 1. And it can be 1 also for inputs 1, 1. Okay, like that we have to write. In any gated latch or any flip-flop, we have to write like this only. Okay, right, remember. Now we'll see Qn n plus 1 values and state values, state names. Okay. So here now I am applying S equal to 0, R equal to 0 and clock value 1. Then what will happen? Go to the circuit diagram. Here it is 0, here it is 0, here it is 1, here it is 1. It means if any one input is 0, output become 1. Any one input is 0, output become 1. It means 1, 1 are going to non-gated latch. When 1, 1 going to non-gated latch, see what will happen? Hold will happen. This hold will happen. So, circuit will become hold. It means n plus 1 become n only. What is the n value? When we apply S0 or 0, n value is 0, so n plus 1 0. And n value 1 also. So that's why n plus 1 value also becoming 1. So this is called hold. 0 is there, 0 is coming, so hold. 1 is there, 1 is coming, so hold. But what's the difference between this hold and these two holds? This hold is happening because of no change in the circuit. No change means circuit is not responding. Okay. However, it is in previous like that only. But here it is responding, but it is giving same as previous output. But here it is responding. That is the triggering. That is the meaning of triggering. Okay, that you have to observe. Now we'll see next condition. What happening when we apply S0 or 1? S0 or 1. We'll go to diagram and we will check. So here I am applying 0 and here 1. Clock is 1, 1. Okay. So if any one input is 0, so it will become 1 here. Here below both are 1, so it will become 0. So it means 1, 0 is going. When 1, 0 going, what is the output? See here. 1, 0 going, what is the output? Reset. Reset value is 0. So reset. Okay. Here reset coming. So reset means value 0, 0. In both cases 0, 0. Okay. Once observe, this 0, 1 is going to gated part, not to latch part. But latch part is getting 1, 0. Okay, that's why reset. That you have to observe. Okay. Next condition. In this case, similarly, you can apply driving part getting 1, 0, but latch part will get to 0, 1. When we get 0, 1, we know it will become set. Then 1, 1 is happening. Latch driving part getting 1, 1, but latch part 2 getting 0, 0 at input. So it will become invalid. So invalid X means here what you have to observe. Here X means 0 or 1. Here X means 0 or 1. Here X means 0 or 1. And here what it means, here invalid means this Qn plus 1 value and Qn plus 1 bar value both are same. That's the meaning. Okay. Now we'll see excitation table. This is step 10. So in the excitation table, we write n plus 1. This n is the present state, n plus 1 is the next state at input side, and we will predict what can be the SR values, input values. When we get n plus 1 these values, what can be the SR values, input value. Like that we do excitation table. Okay. So if there are two inputs means 0 0 0 1 1 0 1 1 will come. 4 combinations. So now how to write this SR values in excitation table we'll see. So what is the n plus first value combination 0 0. Now go to characteristic table. From the characteristic table only we have to write excitation. See n plus 1 value here one time 0 0 and here one time 0. Okay. So here in this two, here 0, here this 0 and this 0. What is the S value? 0 only. So S we are getting same value, so it will be 0. But R we are getting different value. See here 0 it is 1. Whenever different value you have to write like X. Okay, so we will get 0x. For 0 0 we will get 0x. Now we will see for 0 1. But 0 1 is there at one place only. See here this 0 1 there at one place. But 0 0 there at two places. That's why we compared. So for 0 1 only what n plus we can simply write S1 or 0. S1 or 0. Okay. Next we'll see 1 0. S equal to Qn equal to 1 and n plus 1 equal to 0. For 1 0 we are getting 0 1 S0 R1 S0 R1. Now we'll see for n plus 1 1 1 it will be at two places. So here at one place and here at one place. So here what we getting S value 0 and here we are getting 1. So yes we are getting different but R we are getting same. Okay. Same is what we getting are 0 but S different, so we write X. So like that we have to write excitation table. Okay. Now characteristic table. Characteristic table. So what is meant by characteristic table? We have to determine next state Q1 plus 1 value by assuming data inputs and present state as K-map variables. Okay. So from the characteristic table only we have to do characteristic equation. Here we have to determine this n plus 1 next state by assuming this Qn and SR as K-map variables. Okay, this Qn is also called present state or state. Okay, so whatever the 1 values or x values, okay, if we are doing with SOP map, 1 values or x values, we have to substitute those in the K-map and we have to determine the equation. So I substituted and I determined. So I got Qn plus 1 equal to S plus Qn R bar. Okay. So what's the benefit of this one? I can determine Qn plus 1 value by substituting S value and Qn value R value in this equation, right? Okay, that's the benefit. So here, whatever this whole happening, this value is going to this side. Okay, like this from left to right side they are going. But when we take hold in the non-gated latch, how it happened we'll see. This is in gated latch, but how it happened in non-gated latch, that we'll see. See here, hold is happening from top to bottom like this. Okay, but we no need to remember right to left to top to bottom like that. Just I am showing. Observe the difference. In this lecture, we'll see SR NAND gated latch with negative level. So negative level means here we are applying clock or enable negative level 0. Okay, so it will trigger or respond when we apply 0 at clock. So in the symbol we have to show, we have to keep a bubble at clock. Okay, that's the representation. It means we apply outside 0, but inside it will be inverted and inside it will go as 1. Okay, so positive level circuit respond when we apply 1, it will become hold when we apply 0, but a negative level circuit will become hold when we apply 1, but it will respond when we apply 0. Okay, that we have to observe. We'll see. This truth table is the latch part, non-gated truth table that we know. This is the characteristic table. Next excitation, then characteristic equation. This characteristic equation, this excitation table will become same as positive level only. No difference. Okay. Only in the characteristic table we can see the difference in this part, only clock part. Remaining everything same. No difference. So here for negative level, if I apply 1, it will become 4. But if I apply 0, it will respond. But this 0 is becoming invert. Okay. Suppose when I applying 0 0 SR 0 0, what happening will see one condition. So here applying 0 0 and the clock is 0. This will become invert. Ultimately it will become 1 1. So it is becoming same as positive level only. Okay, right? In this lecture, I will explain both positive level and negative level SR NOR gated latches. Okay, separately. Positive level and negative level separately. Okay, first we will discuss positive level. So here why the name NOR latch came? Because latch part is NOR. If this latch part is NAND, it will become NAND latch. Why gated? Because to that latch, there are some driving or gated part is attached at the input side. That's why. Okay. And one more thing we have to observe between gated NAND and gated NOR. In gated NAND, latch part is NAND and driving part also NAND. But in gated NOR, latch part is NOR, but driving part is AND, but not NOR. Okay, remember this. This is applicable to any other latches, gated latches and flip-flops also. Okay. So why we using AND gates here? Because we changed latch to get the same output as gated NAND latch, we have to change these gates. That's the reason. So ultimately, whether it is a gated NAND or gated NOR, the output should be same. Whether it is a gated NAND or gated NOR, it is a latch only. Gated latch only. Gated latch means that should behave same. Even we change the latch part. Okay. Changing the latch part is a different way of construction. But ultimately, the functionality of gated latch should be same. To make the gated latch functionality or behavior same, okay, we are changing the gates in the construction. That's the reason. Okay, but if we take non-gated NAND NOR, they both behave different. The truth table will be different. Okay, that's the drawback there. Okay, some more drawbacks also there with latches. I will discuss later. Okay, so symbol will be same as NAND latch only. Only this logic diagram is changing. Okay, and the remaining all steps and this truth table will change. Latch part truth table because this is now NOR latch. Okay, but remaining this step 2, step 3, step 4, everything is same. No difference. Okay, we'll see one input. Suppose when I apply 0 0 and with positive level clock is 1. So then what will happen here? I am applying 0 0 and this is 1. It means 0 1 1 0. If any input 0, AND gate will become output becomes 0 and here also output becomes 0. Okay, so what going to NOR latch? 0 0 is going. When 0 0 is going, what will become NOR latch? Hold. Okay, same happening. If we do like that, however we got with gated NAND latch with positive level, like that only we can get. Okay, there is no other difference. Now we'll see negative level. Only here we have to keep inverter and here we have to keep bubble. Remaining everything same. Remaining all same as positive. No other difference. Only in this table we know these values will change, clock values. Okay, right.